Hello, ladies and gentlemen. Your normal lecturer has been kidnapped, and I am your substitute lecturer. Nah, I'm just kidding. No, but we're now going to begin with a practical example that's going to be more like of a skills development example, and I'm going to have a couple more of these before we actually start doing problems related to the probabilities of normal random variables, where we're going to be able to put the skills in this example and the next few examples to work. Okay. However, this example is no less important, and I want to show you essential techniques to essential techniques that will be very useful to us in those practical problems that we're going to see at a couple of examples from now. And of course, the nice thing about this example is that this is stripped down. There's less to work with because we're just going to work on the basic skills. What are the basic skills that I'm talking about? Finding the area underneath a normal curve between or subject to certain parameters. Okay, in this case, between, but it could be what it greater than, less than, and things of this nature. Okay, we'll look at those examples. We'll look at other examples soon. Okay, but without further ado, let's read this example and see what it's talking about. What is the area under the standard normal that lies between negative 0.67 and 1.23? Okay. Okay. First thing that must pop out to us is that it's a standard normal. Okay. We've already agreed to denote the standard normal as Z, where Z has the normal distribution with mean 0 and standard deviation 1. Okay. This we've already agreed on. And so the first thing we're going to do before we calculate the area is we're going to draw what this should look like on a picture. What area we want to calculate, we want to picture it. Okay? And I want you guys to get into the habit of drawing pictures too, because that will help you to capture what is being asked. You'll be able to visually verify whether it's capturing the problem statement, and then it'll also help you to develop an intuition for what's happening. Okay? So now this is the standard normal random variable. So we know that the mean is exactly in the middle. And in this case, because it's the standard random normal, the mean is 0. So we know that right here, dead center, is the x value, or is the value of 0. Okay? So now here, we ask ourselves, where is negative 0.67? Well, if this is 0, negative 0.67 must be this way. So I'm going to say it's right here, let's say. Negative 0.67. Okay. What about, where is 1.23? Well, 1.23 will be over here on the right somewhere. Let's say it's right there, okay? So it'll be 1.23. So now we can visualize what's being asked for as the area underneath the standard normal curve, but between these two boundary lines, like this, okay? Okay. Now, even though in this problem, they're only asking us for the area, I want to briefly touch upon how we could interpret this as a probability. As we saw from the first lecture, even though that lecture was in great generality and did not focus on specifics, we did agree there that the area under the standard normal curve between particular x values would represent a probability. And so in this particular case, we can state that, in this particular case, we could interpret it in the following manner. So the interpretation of this area would be as follows. If we had an experiment if we had an experiment which was modeled by the standard normal, okay, then we could interpret this area as the probability that that experiment, which is modeled by the standard normal distribution, takes on a value between negative 0.67 and 1.23. Okay? So that's what this area would represent, or how we could interpret it, right? So again, provided that that an experiment is has the normal distribution, the standard normal distribution, it would be the probability that the experiment takes on a value between negative 0.67 and 1.23. Okay. So now what I want you to do now, all of you, is I want you to look for the standard normal table that you guys have, and I want you guys to verify with me the following fact. Okay? That I'm going to display on the board. Okay? But first, yes, we're going to get to that in a moment, and so I want you to have your standard normal table ready. I want you to look at this drawing. As we know, from the standard normal table, we can find out the following information. Okay, so this is my standard normal, okay? And I know that the standard normal table lets me get cumulative probabilities for the standard normal. What does that mean? That means I start way off to the left and I get all the area under the curve up until some certain z value. So I want you to imagine for a moment visually that I have here the vertical line at z equals 1.23. I can get this area from the table, okay? And I want you guys to start looking for that in the standard normal table for me. Okay? That's a 1.23 right there, right? Now, I'm going to look at it in my table, and I can see, let me see if I can get close enough for you. So I know that at 1.2 and then 3, the area there underneath the curve and to the left is 0.8907. Okay? So here, this area is 0.8907. Right? Now, you might ask me, well, David, who cares? This does not look like this, right? But look what I'm about to do. What I have there is this all the way to the left, right? What if I take away from here to the left? Aha! I can find out how much area is from here into the left, right? Because that's a cumulative probability. So I can find that out, and I'm going to subtract it from this one. So in other words, like geometrically, I'm going to subtract the following figure. And by the way, these are the kind of drawings I want you guys to get used to drawing. Even though these drawings may not be perfect, right? The reality is that by drawing them, it's going to help you guys develop an intuition and a confidence in calculating these things, right? So I'm going to subtract this part you see here, because then when I take away this area from this area, I'm going to be left with that slice, which is exactly this area here. Now, I want you guys to look with me at your standard normal table, and I want you guys to find out what is the area of the standard normal behind z equals 0.67. Okay, so let's look at that together here. Negative 0.67. Okay, now that'll be this column. Okay, it's 0.2514. Okay, 0.2514. Okay, perfect. So I'm going to denote that here with an arrow. 0.2514. Okay? So if I then subtract these, I can see that visually, right, if I subtract these, I'm left with, and I know this is kind of redundant because this is exactly the graph we have up here, but why not? Let me see if I can line these up really nicely. Yeah, that one lined up there. This one lined up here. Here. Right, and what is the area here? I'm going to mark that. right? So it looks like this. You can see that because I took away this area from that area, that part is gone, right? And because I had all this extra area here that was shaded on the top, and I'm not taking away any of that, I'm left with this part in the middle shaded, just as we need it to be. That corresponds exactly to this area. I also know that the area under the standard normal curve from all the way to the left at negative infinity all the way to 1.23 is 0.8907. I know that the area from the negative infinity all the way up to negative 0.67 is 0.2514. So what is this area? It's 0.8907 minus 0.2514. Let me do that over here real briefly. Can you guys see this? Oh, yes. So 0.8907 minus 0.2514 yields 7 minus 4 is 3. 0 minus 1, I can't do that. So I borrow from this 9. This becomes an 8, and this becomes a 10. 10 minus 1 is 9. 8 minus 5 is 3. 8 minus 2 is 6. And then I bring my decimal point down. 0.6393. Okay. And so finally, we're able to state the answer to this problem. The area underneath the standard normal curve from negative 0.67 to 1.23 is 0.6393. Okay, and if this was a practical problem, and we were talking about an experiment that was modeled by a random variable that just happened to be the standard normal random variable, we could interpret this 0.6393 as the probability that that experiment took on a value between negative 0.67 and 1.23. Okay. I hope that you've enjoyed this example, and I look forward to seeing you again soon. Thank you so much.